Yo, Coach Ray back at it. Today's lesson is called Solving Real-World Rational Equations. Okay, solving real-world rational equations. All right, so I don't want to insult you by reading to you, but I'm just going to read it out loud anyway. We are dealing with painting a room today. All right, when working together, it takes Cam, Caleb, and Tyson 2 hours to paint a room. Okay, so that's the information that they're giving us. Next thing they're giving us, if Cam were to paint this room alone, he can paint the room in 6 hours. Valuable information. When Caleb works alone, he can paint the same room in 4 hours, so Caleb's better than Cam. Okay, and what we're trying to find out is how long it would take Tyson to paint the room on his own. If I owned a painting company and I had employees working for me, this could be very valuable information. Okay, I could have a general idea of how fast my employees work to paint an average sized room, and that might make me base decisions off who I want working together, who I want to send to what job, that type of thing. So this is real world applicable. I love doing problems that are actually real world, and I think this one is. All right, now we're going to do some math. We're going to set up an equation. We're going to do some math. We're going to figure out how long it takes Tyson to paint the room. Is that going to be an exact, accurate number? No, because we're dealing with real people. Okay? Like, real people complicate things. Right? So it's just going to be a general idea. Alright? Like, I could do a full statistical analysis on the Tennessee Titans versus the Kansas City Chiefs that are coming up this weekend. And all of my data where I do all these spreadsheets and everything could tell me that the Chiefs are going to win by 7. Is that for sure? No. Because there's real people involved. People might get hurt. Who knows? People could get sick. We don't know what's going to happen. Real people kind of mess things up. But it gives us an idea, so it's still very valuable to have. Make sense? Okay. So let's figure out this Tyson guy. I'm going to ignore the fact that when they work together, they can do it in 2 hours to start. I'm going to start with each of them as individuals. Okay? This is the part that's really hard to explain, but I'm going to do my best. What we're going to do is kind of convert all of them to what they can do in 1 hour. All right? So Cam's dealing with 6 hours. Caleb's dealing with 4 hours. We don't know on Tyson. The whole group is 2 hours. I want to convert everybody to 1 hour so we can just all be on the same wavelength. And the reason I'm picking 1 hour is it's really easy to do. Okay? So here's my first question. When Cam works alone, he can paint the room in 6 hours. How much of the room can Cam paint in 1 hour? 1/6. Is that obvious? Okay. If Cam started in that corner and was painting, and it took him 6 hours to get back to the beginning, in 1 hour, he would have 1/6 of it done. Easy. Okay. So I'm going to represent Cam with 1/6. He is going to take care of 1/6 of the room. Okay, Caleb can paint the room in 4 hours. So in 1 hour, how much can he paint? 1/4. All right, so just so we're clear, if we started Cam in one corner of the room, and we start Caleb in another corner of the room, after 1 hour, Caleb's going to have 1/4 of the room done, Cam's going to have 1/6 of the room done, Caleb's going to turn around and be like, bro, hurry up, what's taking you so long? I already got 1/4 of the room done, blah, blah, blah. Okay? All right, so 1/6 of the room and 1/4 of the room are being taken care of so far. How are we going to represent Tyson? X is going to be involved because we don't know about Tyson. Okay? But more specifically, when I write this equation, how am I going to represent Tyson? 1/X. Okay? And the reason is Tyson's going to paint a fraction of the room. Right? Caleb's got a fraction of the room. Cam's got a fraction of the room. Tyson's got a fraction of the room. None of them are painting the whole room on their own when they're working together. So they're all painting a fraction of the room. The problem is, we just don't know what fraction of the room Tyson's going to paint because we don't know how fast Tyson paints yet. You good with that? Okay, let's talk about if all of them work together. Get all 3 boys in the room together. Okay? They can paint the room in 2 hours. Let's convert it to 1 hour. If all 3 boys are in the room and it takes them 2 hours to paint it, how much can they paint in 1 hour? Half the room. Is that obvious? In the first hour, they paint the first half. Second hour, they paint the second half, and then they're done. Okay? So I'm going to write that as 1/2. in turning this into an equation, I hope makes sense. Cam, Caleb, Tyson, if they work together, adding their work together, it's going to equal them painting 1/2 of the room in 1 hour. Okay, so Cam's going to paint 1/6, Caleb's going to paint 1/4, Tyson's going to paint 1 something, and that's going to equal half the room, and all of that we're talking about 1 hour. I just want to pause there and make sure we're okay. Solving it is next, and that's a whole different story. Just want to make sure we're okay up to this point. Okay, if the time measurement were different, this is super unrealistic, but if the problem said Cam can paint the room in 6 minutes, all right, so don't start converting minutes to hours and all of that. Then we're just going to say, how much of the room can Cam paint in 1 minute? He would paint 1/6 of the room in 1 minute. Okay, same thing. If they were talking about minutes and Caleb could paint the room in 4 minutes, we just say, how much can he paint in 1 minute? It would be 1/4 of the room. Everybody good? All right. Solving. Just like what we did in our last lesson with our last assignment, we need to multiply all the numerators by something that gets rid of all the denominators. So we got to cancel out every single denominator because I want my next line to have no fractions. Okay, so I need all my denominators to cancel. And other major key, I need to make sure I multiply all 4 terms by the same thing. All right, I'm going to start with my variable. If I want this variable of x to cancel out, what needs to be on top? X, right? So I'm going to do times by x. Now I know that that's going to cancel out. But I know I've got to multiply every term by the same thing, right? So right now I'm just going to go ahead and put a times x at the top of all of these. Is that x going to get all my denominators to cancel out? No, it's only going to get one of them to cancel out. But I know I've got to do the same thing times all of them. So I'm going to just write it right there for all of them. So far so good? Okay. I need all my numbers to cancel out. We did an example on the board last time that looks like this. That is a really weird way of writing the number 48. But if I multiplied each numerator times that 6 times 4 times 2, 6 times 4 times 2, 6 times, on to all of them, is it obvious that the 6 would cancel with the 6 in the first term, 4 would cancel with the 4 in the second term, 2 would cancel with the 2 in the last term? We could use that. That'll work. There's also a smaller number that would work, though. 2 won't work because if we put a 2 over top of this 6, the 2 in the 6, you're right, would reduce, but we would still have a 3 in the denominator. Say it again. 12. Nice job. If we multiplied them all by 12, 12 over 6 is just going to reduce to be the whole number 2. Okay, over here, multiply this by 12. 12 over 4 is going to reduce to be the whole number 3. Okay, this one, the x is gone anyway. And this one, whoa. It scared the crap out of me. My phone just rang. Okay, I think we're good. Are we still recording? That's never happened before. Alright, we're still recording. Alright, now this video is weird. That's fine. Alright, eyes up front. Eyes up front. So now, multiplying by 12 everywhere is going to get everything to cancel out. So let's do that now. So 12 over 6 in this first term, that's going to turn into the whole number 2. The other thing I could do is I could cross cancel. Okay, so if I cross cancel here, this turns into a 1, that turns into a 2. So 2 times 1 times x is 2x. Okay, here, 12 over 4 is going to be the whole number 3, and then 3 times 1 times x is going to be 3x. Here my x's just cancel, so all I have left is 12 times 1, which is 12. Okay, and here 12 over 2, that's going to be 6 times 1 times x, so that's 6x. And I want to pause there, just make sure everybody's okay, but I successfully found something, the same thing, that I can multiply times all the numerators, that would get all my denominators to cancel out, so now my green line has no fractions. And I would make the claim that that green line is now an Algebra 1-2 problem. That's something you, whenever you took Algebra 1-2, you could solve it then. Okay, so let's do that. Combine some like terms. 2x and 3x is 5x. Okay, I'm going to do minus 5x on both sides. So I've got 12 equals 6x minus 5x is 1x, which is the same thing as x. So I get an answer of x equals 12. Is that right? Yes. All right, so what does that mean in English? Remember, we're talking about a room and paint. What does that mean in English?
You could do it in the
Who can paint in 12 hours? Tyson. Tyson can paint this room in 12 hours. What a bum. If I was Cam and Caleb, I'd be like, Tyson, bro, we're good. You could just hand me a paintbrush every now and then. We'll take care of it. Okay? But that is how you solve a real-world rational equation.
I've never seen a question like that.
That's it for this video. Appreciate everyone checking in. We'll be back with another video soon. Deuces.